Welcome everybody to our part of the briefing. My name is Tom and this is Giulio. And as Will said, we are here today to introduce to you a tool that we've developed in-house for data visualization in the context of threat hunting. And that tool is Detectree. So the customary who am I or who are we slide. This is us in our day-to-day. We'll start with me. So yeah, my name is Tom. I'm a threat hunter, and I joined WithSecure back in June of 2020. I started my cybersecurity career at Darktrace, and then have worked at another machine learning focused cybersecurity startups in the meantime. Before that, my education was a physics degree from the University of Bristol. And interests include electronic music, Settlers of Catan, and as Will mentioned, Liverpool FC. So yeah, happy to chat about. I see a thumbs up over there. Good stuff. Giulio?
Hi everyone, I'm Giulio. I joined WithSecure in March 2020, and before that I was just in university. As you can see, I come from Italy. I did a master's degree in cybersecurity in Rome. I then, before that, took place in some research projects in university still in Finland. And my interests are electronics, not electronic music, and planes, travel, and as you can see, Christmas hats.
I'm going to start the conversation with what I'm going to call the data problem, or it might be a lack of problem, depending on your perspective. But that problem is what is shown by the two red lines here. This is an Elasticsearch index that we have access to in our managed detection and response team. And within 15 minutes, we've got nearly 34 million hits that have come in. And I think this is quite prevalent within blue teams in general. It's the fact that we generally have more data than we know what to do with. It's not our ability to harvest data from computer networks that's the issue anymore. It's now what we do with that data that's the challenge. And within the last 10, 15 years, we've seen a renaissance in the fields of machine learning within data science as a step to try and efficiently make sense of large data sets like this. And they really have helped. We are implementing such solutions currently in our service. But an often overlooked part of those two disciplines is data visualization. I think perhaps because it doesn't carry the same mathematical rigor as things like data science and machine learning, that they're often not marketed in the same way. They're not quite as sellable. But data visualization is intrinsically linked within those two disciplines. And as we're going to show you, can go a long way in turning large corpuses of data into something meaningful. So I'm going to put a quote up on the screen that you've probably never seen before. It's defenders think in lists, attackers think in graphs. As long as this is true, attackers win, from John Lambert back in 2015. And what we want to show you today is us as defenders beginning to think and work in graphs. Cool, so I'm going to go and look at why we fundamentally visualize data. This is a picture from a book called Information Visualization, Perception for Design, written by Colin Ware back in 1999. And I'm just going to bring up a couple of quotes from the same book that we'll read through together. So fundamentally, why visualize data? Well, it's because the human visual system is a pattern seeker of enormous power and subtlety. The eye and the visual cortex of the brain form a massively parallel processor that provides the highest bandwidth channel into human cognitive centers. A second quote, we can easily see patterns presented in certain ways, but if they are presented in other ways, they become invisible. Following perception-based rules, we can present our data in such a way that the important and informative patterns stand out. And as we can see, simply by introducing another dimension into this picture, the dimension of color, we can allow the human, the pattern seeker that is the visual system, to simply do its work almost instantly. We are automatically drawn to objects, to patterns within the data that when it's grayscale, don't exist or don't appear to exist. This is maybe a trivial example, but begins to explore and begins to show reasoning behind what Colin Ware was saying. So if we just summarize the key takeaways from these quotes, they are that the human visual system is a natural and powerful processor. Is this something that we can use to our advantage? And that patterns are dependent on how data is presented. So how can we then take the fundamentals of data visualization and apply these to a cybersecurity context? So again, thank you, Nick, earlier for the warm-up, but we're going to talk about a well-known data visualization tool, which is Bloodhound. As Nick has already explained, Bloodhound allows it's the graphical representation of relationships within an Active Directory domain, and can allow for a red team and now a blue team to see attack paths that can be exploited for lateral movement and privilege escalation. The great thing about Bloodhound is the fact that the data it was using had been around for years. It exists in almost every computer network environment. It is simply Active Directory information, but then presented in a way that is intuitive to an analyst, that triggers meaning almost instantly. Another example of showing data graphically is the VirusTotal's graphing tool. This shows the relationships between IOCs. So we've got network addresses, we've got executables, we've got even threat actor groups at the top there. And again, allows a human almost instantly to make links to form relationships between these artifacts, sometimes with multiple degrees of separation, that if we were simply thinking in lists, if we were simply reading this in a text format, would be much harder and much more cumbersome to uncover. Maybe a lesser known example is a tool called Procdot. Procdot is a local tool that ingests telemetry from Wireshark, so network telemetry on an endpoint, and the process telemetry from a tool, Procmon. It marries these two telemetry sources and then, again, presents that previously text-based data in a visual way that a human can see. The human visual system can be used to form some sort of understanding about what's transpired on the event, on the endpoint, sorry. It's quite clear from this picture if you can read the text. I apologize if it's a bit small, but we've got a process spawning another process that's then carrying out some file interactions on the right-hand side there. Something that is available from Procmon, and, well, there's no network information here, but Wireshark as well. But looking at this graph, we are almost instantly getting that context, that understanding of what's happened. And then the final existing tool I'll talk about is the humble process tree. Regardless of whether you've used those tools, the previous tools in your day-to-day jobs, you'll have likely encountered a process tree. It's a simple representation of the parent-child relationships within processes on an endpoint, and again, is so elegant in what it does because it takes a number of data points and presents this in one image that we can look at and understand, right, these 6 processes on the right-hand side were ultimately spawned by what we've got in the left-hand node. This is, again, maybe a trivial example. This is simply the processes responsible for the Windows logon process, but goes a long way to demonstrate my point. So all that these tools are doing is taking data, sometimes unstructured data, but with relationships built in, and then presenting this in a way that is intuitive and natural for a human to look at. So within our MDR service, how can then we do the same? And I think Giulio's going to talk to you about that.
Thank you, Tom. So if we now have a look at some of the example data that we get from any detection backend, we can see them here presented in a list format, and I'll now go through each one of the columns to understand what we're looking at, but you can see that it's already quite a hard job to understand what is what. So if we start from the far left column, we see the parent process. This is the parent process name of a program that has spawned another program we are interested in tracking. And in the same way, the second column is the parent PID, so it's the unique identifier of this parent process. And we got two other information, which are process name, is the name of the process we are interested in tracking and that has performed something interesting on the endpoint, and we got the unique identifier for that process as well. So with these three columns, with these three information, we can start building our process chain of what is interesting to look at, what should be prioritized, and what has caused what. If we then go to the fifth column, we can see the detection name. This is the friendly name of why we are interested in looking at the previous processes. And the last column is the, apologies if it's not very clear, but is the severity. These will help us prioritize what process should be looked at first. You can see that we can start, if we now move to the rows, we can start from the first row, see that that CMD process with PID 8988 has spawned net.exe with a specific PID and has spawned three other interesting processes, that same CMD, which are whoami, net, ipconfig. We can now say, okay, let's look at what has spawned that CMD and walk up the chain. We can see in the fifth row that we have CMD being spawned by a suspicious TMP file. This is what we usually do to understand what is happening on an endpoint and to understand what processes should be investigated, what we should prioritize, and so on. But if we now, you can see that this is a difficult task to do just by looking at this form of data. If we now switch to a different visualization of this same data, you can see that this is a much more intuitive, fast, and efficient way of looking at that same data that we were seeing before. So I'm now going to quickly go through what each node is and what they mean so you can understand how to read this graph. If we look at the nodes that have different colors, they are what we call application nodes. They, each color represents a detection. They can range from no detection up to critical severity detections. And this indicates the node we are most interested in. We then have context nodes, which are what we show on the far left. If we see the legend, they are the bottom three nodes. They are network file and registry nodes. And they are in the graph, for example, in the top part there, we can see an internal IP address, which is getting some connections from PowerShell, another executable, and something else. And you can see also that same PowerShell executable there at the top interacting with some interesting files there. So this representation is a much faster and efficient way of looking at the data that we have just seen in the previous slide and in the table format. We now have a small demo for you. So if we now look at this example here, we have two different subgraphs, one on the left and one on the right. The one on the left, it seems to be performing some form of enumeration. And if we hover over a node, on the bottom part, we can see that this is related to a specific user. In this case, it's Marvis. And we can also see the detection that are connected with these nodes. This, again, seems to be performing some enumeration through CMD. In the same way, if we look at the right subgraph, we can see that this is related to the health check user. So it's another user that might have been compromised. And this is performing something a bit more interesting. We can see something at the top, some enumeration again, some programs being run. We can see at the bottom there, or in the middle, there is an LSAS process being injected, which is the dotted red arrow, from m.exe. This might be an indicator which is in line with Mimikatz, for example, extracting hashes from LSAS. And again, at the bottom there, we can see another Lenovo update, which is the same program that has the origin from there. But if we add some more context with the context node, we can now gather a bit more information, situation awareness as well, and we can see that the two Lenovo updates are communicating with a unique IP there. They are linked by that, so they might be, they are from the same chain of compromise, and a lot of programs are also communicating with the internal domain controller, and this might be a form of enumeration, privilege escalation, lateral movement, whatever. We can add some further context by adding file nodes, and we can see in the top part there that we have some interaction with 3 suspicious files, and some of these files, such as m.exe, the right one, is also being executed there by Lenovo update. And if we go at the bottom there, we can see another suspicious program, p.exe, interacting with the Lenovo update executable, so the one that we have a detection with, on an admin share on the domain controller. I believe you can see it, hopefully. And we can add more context by adding registry nodes. And we can see that in this case, this p.exe is also interacting with a registry key linked with psexec. So this is likely psexec, trying to move on the DC. So with zooming out, we can see how much easier it is to just investigate a possible compromise using a graph format instead of just using a textual format in the way in which we are used to. And we can also see that even without the context, it is much easier to just look at this kind of data in this format than just having a textual representation, which, if we move in the next slide, this is how you would normally investigate this kind of compromise. This is the exact same data again that we have just seen in the demo, but it's just in another format, in a much more difficult format to understand, in my opinion.
Yeah, simply by launching the program and toggling on something like network connections, we were able to join 2 process trees that were previously considered unrelated from 2 users that may have been 2 attackers on an endpoint. By just simply introducing that context, we were able to link that activity almost instantly. But I'm going to talk about some direct impact that we've seen from Detectree within our service, within using the MDR service. The first one is a reduced time to response. This exploitation of the powerful processor that Colin Ware was talking about in his book gives us that head start. When we come to information, we're able to immediately understand at least a high-level context of what's happened. Then by using the tool, we can further dig in to the IOCs, the artifacts of interest. We're kind of treating processors and network addresses and registry keys, etc., as all nodes, all artifacts here that can be investigated. So the graphical way of viewing this data reduces our time to response, which is ultimately what we're striving to do when we're delivering a service to clients. This then goes hand in hand with the reduction in alert fatigue. This is something that's talked about a lot in the industry, especially these days. When people are responding to detections that may represent cybersecurity attacks, maybe during an 8 to 12-hour shift even, this does take its toll. Perhaps attention levels are not as high at the end of a shift as they were at the beginning. And this reduced time to response, reduced time to meaning, lends itself to the reduction in alert fatigue. But then this reduction also comes from another avenue, and that's the fact that we're doing the analysis in a much more natural method now. If anyone's read Thinking Fast and Slow by Daniel Kahneman, this is kind of analogous from going from system 2, which is this effortful, conscious way of trying to draw meaning from data, over to system 1, which is this instinctive, intuitive, human way of making patterns from information. And then finally, it facilitates communication within the team. I've always thought of data visualization as a way that data existing on paper or on a computer is communicated to a human, but it also facilitates communication between humans. When we're doing a post-incident review now, if we want to discuss what steps an attacker took on an endpoint, we will always go to Detectree as that first tool that we use now because of that shorter time for an analyst to be able to understand the context of activity. I'll use another cliche. A picture tells 1,000 words. We don't have to sit there line by line explaining text-based data that's often represented chronologically, but chronology doesn't often reflect causation. And in a tool like Detectree, the causation is clear, and that facilitates the communication between analysts. And I'm going to touch on some future work. Now that we've open sourced the tool, we've kind of done a V1 that's ready for people to use. Future work, the first I'd like to talk about is the application of machine learning to the data that underpins Detectree. For anyone that's spent 5 minutes with me talking about cybersecurity probably knows that I'm pretty into the application of machine learning to cybersecurity. And now that we've got this data saved off in a graphical format, whether that's an adjacency matrix like we see here or an incidence matrix, we can begin to explore the quite emerging field, which is graph machine learning. We've currently got quite good success in some models that we use internally by taking groups of detections and determining whether these are similar to other groups of detections that we've seen before, or whether these are likely to be a group of detections that represents malicious activity. But generally, machine learning takes unrelated samples and data points in isolation of each other, whereas when we represent the detections in a connected way, then we can begin to bake in those relationships into the model that we're giving it. So we expect to see some improvements to our machine learning models if we were to feed it the data that underpins Detectree. And then maybe a less formal piece of future work is around the change of conventions with which we deliver a cybersecurity service. I think blue teams often default to this understanding of a compromised host or a compromised user, or then maybe compromised individual artifacts. But can we sit somewhere in the middle? By looking at a causation tree like Detectree, can we take a tree or a subtree as compromised? Can we then, instead of maybe isolating a host, instead of rolling a user's credentials or blocking a user from doing certain things, can we simply remediate an artifact tree? This then restricts our remediation to make it finer, more accurate, and ultimately we can treat things like processors, files, network addresses as all compromised artifacts and begin to take a more targeted approach during the remediation phase of investigation. I think Giulio's now going to just talk about the open source repository.
Yeah, so as we said, the tool is open source. It will be made open source right after this talk, so it's not open source yet, but will be very soon. You can find it on the Countercept GitHub page, find the link up there, and we'll probably follow up with some blog posts as well. So watch the Countercept page on GitHub. And that concludes our talk as well.